Good morning. What is up, Johnny, my friend? Nice to see you today. Right, I have two more things wrangled here, so let's see. There we are. All right, yes. Okay. Good morning. Welcome. Get to browser, which is over here. For anyone who's new, if you don't know, if you haven't caught the stream before, my name is Tim. I go by Foamy Guy here on on the Discord, which is the chat below me right here, and on GitHub as well, and a few other places. I usually stream at this time. Sorry, I got something in my eye right now for some reason. I usually stream at this time each week, Saturday mornings around 10 a.m. Central Time, working on some stuff related to CircuitPython. If you don't know what CircuitPython is, you'll learn more about it at the main website for it here, circuitpython.org. It is basically a version of Python that can run on these tiny computers that are called microcontrollers. Many of them are just a single chip on these little breakout boards, and there's other other little components to go along with it. But the microcontroller itself is sort of the main chip that drives these little boards. CircuitPython is a way to write programs for these microcontrollers. So you plug it into your computer with a USB cable. It shows up like a thumb drive. You can save a Python code file that's on that thumb drive. You can write your code into it and save it. When you save it, the microcontroller will actually interpret and execute that Python code for you right there on the microcontroller. And then your code can interface with all sorts of other electronical doodads, bits and bobs, widgets that you connect to your microcontroller. So you can have inputs like knobs and buttons and sensors. You can have outputs like lights and displays and e-ink screens and LED matrices and speakers and all kinds of things. And if you choose to use CircuitPython, then you can write Python code and just save it on your device like a thumb drive in order to interface with all the rest of those hardware peripherals. CircuitPython is an open source project. It is free to use. It is free to port support for your own device. So if you are a company or a person who has made a microcontroller and you want to add support for CircuitPython to it, it's totally open source. It's totally free to do that. All of the software and everything is published under permissive licenses. Adafruit is a hardware and software company based out of New York. They're the ones who make it possible to have CircuitPython and publish it under that license and all that stuff, right? So they pay a team of folks, including myself, developers and people who write guides and documentation and people who do support, all kinds of different stuff to work on CircuitPython and lots of other surrounding open source projects as well. If you would like to help support them and all of the great work that they pay for to be open sourced, one of the easiest ways you can do that is by purchasing hardware from them, which you can do on their website, adafruit.com. Remember, weekly sales are going on, so it's clearance sale week, extra 40 to 60% off of select items, and there is a huge selection of items. So I don't know if you can see my scroll bar. No, not really, because it's behind my head. I'll move it down here, and it's behind the chat, which makes it maybe slightly more visible, but the point is this is a big list. So have a stroll through here. You might find something that's interesting, and it will be steeply discounted on account of the clearance sale week. However, I would recommend, if you want to get that deal, to jump on it pretty quick, because I think they have been changing either on Sunday or Monday. I'm not sure when, so might be last day or maybe day or two to get that. So gonna want to jump on it if you want to see what's there and get some goodies. So let's see. Johnny says, just added an on-air sign that lights up when there's a live stream. Oh, nice. That's a cool idea. On-air sign. Yeah, I think maybe Liz or somebody did an on-air sign in the more traditional sense of like put it outside your room or on your door or whatever, and you turn it on whenever you're going to be live or whatever. Say I saw that on Learn at some point, but I don't remember for sure what if it was a screen or a matrix portal or what, but it's pretty cool. On-air sign. All right. So we are diving in this morning. First, I wanted to show some of this work that I have done this week. If you caught my stream over on the Adafruit channel on Tuesday, I was working on sort of the beginning stages of what I'll show now. So back on Tuesday, I was just in the beginning steps of getting the Arduino CLI working and getting the I2C debug serial is what it's called on the Arduino side, and debug I2C is what it's called on the CircuitPython side. Getting those things running so that we could interface with an I2C driver, an I2C breakout, and see the actual raw bytes, the raw traffic going back and forth in those I2C read and write transactions. And we got that working on Tuesday, and I have built a bit more since then to build out. One thing is this I2C test validation, or test I2C validation rather, which is a PyTest script that will run a series of tests using that CLI stuff that we did on Tuesday to be able to print all those raw bytes out. It will run a set of tests, one on CircuitPython, one on Arduino, and then it will compare the outputs of all those I2C transactions. And in fact, why don't I show what I'm doing instead of the whole finger puppet thing here. Let's go agent this way. Nope, this is wrong. We're already on agent. We just need to go to the home directory, Arduino, and this is inside of here. And then I want to go inside of here as well. So right now I have both a Arduino, or I should say actually it's an Adafruit Metro, which is compatible with Arduino Uno form factor. Maybe, or is it Leonardo? I'm not sure actually which one. I think it's Uno. At least that's what I think I set the Arduino CLI for. So maybe it works either way. I'm not sure on that part. But in any case, this is an Adafruit Metro, which is an Arduino compatible board. Fruit Jam, of course, RP2350 there, not plugged in. We should probably do that. There we go. Fruit Jam plugged in now. And into both of these boards, I have connected a LIS3 MDL, which is not a particularly special thing. It just happens to be an I2C breakout that I had two of. I have two of the exact same ones. So there's one connected to the Fruit Jam here with a stemma cable. There's one connected to the Metro here with also a stemma sort of breakout cable thing. So those are connected, and then when we run the tests, it will basically produce something like this. So I could go the Arduino one, and we need to use the runner for this, which is in the Python, well, which is a Python script, which means we need to be in the Python virtual environment. That. One of the things that I don't care for about this is the way that it's kind of assuming that this runner script will be up here. I may go back and fix that. I don't know if I'll do it on the stream, but at some point I think I'll refactor where it expects these things to be. But right now that's how it works. So we go up one, Arduino runner. This we can tell it what we want to run. So we can go, I happen to have some Arduino tests written here. If I look inside of this one, we can see the actual tests that we have. So LIS3 MDL test. So this is where I'm at there in the terminal. And inside of Arduino tests, I have 0, 1, 2, 3, and 4. So 0 is a chip ID test, and then there's range, data rate, performance mode, operation mode. Those are the configuration registers for this particular device, LIS3 MDL. But again, like ultimately, I'm aiming for a general thing here. This just happens to be a sensor I had two of to be able to plug into both. devices at the same time. All right, so we've got these tests inside of it. It is just a very basic, so the chip ID is the most basic one. One thing that's, I guess, a little bit extra in it is it does this initial reset, essentially. This is resetting the breakout before we do anything else, and it's doing it outside of the debug stream so that we won't see these things get written in that sort of raw bytes debug output. And the reason we want that is we want to put the sensor into a known ready state, a default state, before we start our debug logging, because if we don't, then it could be left over in a different state from the previous test or from the previous code if it wasn't a test. Like, there's no telling what state the sensor is in, and because anytime we do a write to an I2C register, we actually also do a read directly before. So we read what's there, we shift in the bits we want to write, and then we write it back to the I2C bus. What that means, though, is because we're reading, if the sensors aren't in like a known, baseline default state, then we could read, and it could be like a configuration from the last program we ran or something on one, on the Arduino side, but then it's different on the CircuitPython side. So this is like reset it back to a known state outside the debug stream. And from that point afterwards, it's just a super basic initialize the sensor, run the begin thing, print the chip ID, which in this case, it happens to, or not print, but actually just validate the chip ID, which in this case, it actually does it inside of the constructor there. Or not the constructor, I guess, but the begin function. So this will initialize it. It will hook it up over the I2C bus. Internally inside that begin function, it's going to do the chip ID test. And then here at the very end of this script, it sets it into a powered down. So like this is essentially more of the same of this. We want to power it down to a known state so that the next time we run a similar sort of thing, we're starting from a baseline. Perhaps probably redundant to do both of these, I'm not sure, but both of them were added around the same time when I was trying to fix this issue of the prior state mattering for the test, basically. So that's the chip ID test, and I'll show you the kind of output it produces here. 0, 0. You can run it on the Arduino device here. This will do its little flashy flash when it's flashing the code. And then this is basically what it outputs. So you get to see all of the transactions on the I2C bus, all the writes, all the reads. This device has a device ID of 1C. And so we went to write something to this register address, and we wrote nothing, which I think signifies that we're reading. So the value we read back was this. Next, we want to read from this, it looks like. So we wrote to it, and then we read back, and we got this. Now we want to write to here, and we actually have some data this time, so we do that, and then afterwards we're going to go and read that data to see if it came back. So it's going to get this same register again, so it kind of goes through and does all these different things. And it's outputting all these raw bytes as it does it. So this was the Arduino one, and then we can run the CircuitPython one basically the same way. Python runner, CircuitPython tests, and there is an analogous chip ID thing. So here, this is basically the CircuitPython code that does the same stuff as that Arduino code. So reset the device outside of the debug bus so that we're not seeing the traffic, but it is getting reset back to a known good state. Then initialize the device using the actual debug bus so that we see all the transactions. In this case, again, the chip ID thing happens internally inside of a NIT, and then we just go to shut down at the very end with power down mode, same as the Arduino did. And so if we run that one, we can see on the camera, we'll get the flashies on this one now. Oh, we got a input-output error, actually. Interesting. Input-output error. Let's try it again. Oh, there's a timeout duration. So because this got an error, actually, Basically, the way it works is this CircuitPython runner script, it has a timeout duration. It will wait for X amount of seconds listening for serial output from the CircuitPython device. If it sees this thing, this tilde tilde end, then it will stop and return early. Because we got this error, and because the code has no like try catch finally print the end thing inside of finally, this was running for 30 seconds or 60 seconds or whatever the default is, basically. But it did actually still register my up and enter, and it ran again, and the next time it ran, as you can see, it seemed to work. So I don't know what the issue was the first time, but we're good to go here now. So, and we can see basically the same sort of stuff. All of these transactions. Now, keen-eyed folks might notice some slight differences, like uppercase instead of lowercase, and also the stop things out here. These are not there. But otherwise, it's effectively all the same stuff getting printed out and in the same syntax even. It's just, you know, those slight differences, uppercase and the stop thing. But these things all get printed. And so the test, the PyTest script, this one here, test I2C validation, this is basically going to run each of those pairs. So it's going to run 00 chip ID on the Arduino. It's going to run 00 chip ID on the CircuitPython. It's going to get that input, that output, I should say, that debugging output, all of this stuff here. And it's going to run through it and compare and check at every single one of these reads and writes, was the data the exact same or not? And if it's not, then the test will fail. And if it is, then the test will pass. And then there are... So that was the chip ID test, and we go through the rest of the configuration registers as well. So any kind of like settings thing that breakout supports, we would test this way. So for the LIS3MDL, that's like there's a range, there's a data rate, there's a performance mode, there's an operation mode, and those are basically the only configurations. And so we have those tests written out, and they work the exact same way. They just do, you know, whatever thing they're going to do. They set it to each of the valid values. So like range is a good example of this. There are, I think, 4 different valid values of range. So it's like 4, 8, 12, and 16. And so these ones go through and they set the setting to each valid value in succession. And it also reads it back out afterwards to verify that the write succeeded. So it writes it, and then it immediately reads it back to make sure it's got the right thing in it. And then same deal is happening where these print all of this stuff, and the test will go through and validate that they are matching. So that's this test here. And I'll run it. We don't have to wait for it to finish. It does take about a minute or so, maybe a little bit longer. I think it's about 20 seconds per test, essentially 10 per device, 10 seconds per device. It is easy to run. We just go PyTest, and then it is I2C validator, or it's, what is it? Test I2. I keep getting these backwards. There's a couple of different options. The defaults are pretty good, though. I've noticed it says -V a lot. I'm not sure what that one, it just prints extra stuff. I'm not sure. But see, this one did its flashy thing and then finished. This one's now in REPL because it's writing the code. Oh, that failed again. So this is going to probably make the test fail. We got the red blinks there, which actually indicates the CircuitPython code did not succeed. I wonder if we got that input-output error again. This thing here, possibly. And unfortunately, in that case, it does mean it's going to go for the full duration. So it's going to wait like whatever the default is, I think 30 seconds, before it recognizes that the test failed. And then it will move on to the next test. So it'll go down the whole line of 0 through 4. It didn't, actually, the -V, it didn't really output anything more. I thought it was going to be showing the real output, but it doesn't actually. Okay, that one succeeded. We saw a green flash there real quick. Which should be an indication that one succeeded. Though if it succeeded and it printed end, it should also have moved on faster, I thought. So we'll see. Maybe it's still going to fail. Maybe the Arduino one was different this time. One says it failed as well. I'm kind of curious, are any of them going to succeed? I actually did run all of these tests successfully. I wish I could see the output as they ran. I kind of thought maybe that's what the -v was going to do. Not seem to be the case. To modify the test to actually print whatever it gets from the runner script. I think it will print some at the end, but it'd be nice to be able to see it as it goes. Yeah, every single one is failing. It's odd, though. I wonder why they are failing. Like, the first one, the CircuitPython code failed because these turned red, which makes me think it was likely to be this thing again, or something similar. But ever since that one, the lights have been green, which indicates that CircuitPython code would have ran successfully. So now I'm kind of curious. I don't super duper want to just sit around and wait for it, but I am kind of curious. Because after it ends, I do think it will go back and print more useful stuff that tell us like where it failed, basically. That was green again. Did I say, do I have TO open or something that blocked the serial? But that would it have failed early? Wouldn't have failed earlier, I'm not sure. Okay, all the CircuitPython ones failed, basically. Yeah. All the CircuitPython ones failed. None of them printed any I2C transactions. I don't know why the lights blinked red, but none of them actually outputted any transactions. Which is the exact same thing we saw when we tried this the first time. Or it's likely to be. That it is odd. Now I can run it a few times and it works. Yeah, I don't know. Maybe when I was jostling the cables around to show it on the camera, I got the, like, I maybe just need to unplug, replug. Just needs to be reseated or something. Because now, I mean, I haven't changed anything and now they're all passing. And you can see how they go much sort of quicker when they pass because of that end marker. It allows the runner to finish earlier, which then allows the test to finish earlier. So yeah, about a minute for the full current 5 tests that exist. Okay, so that's the test, and that's kind of the concept of what it's doing. And then sort of the one level up from this that I have done as well is write out this skill file, or refine the skill file that was written by Claude. Which is an agent skill that is centered around running the test, running this test, and also writing the validation test. So like writing this chip ID test and making sure to do this reset thing here and making sure to do this stuff at the end, and making sure to use debug I2C. So this is like a markdown file which basically documents how to write those tests on the Arduino side, how to write them on the CircuitPython side, the special stuff to consider on each, and then how to run the test. And then also, as I was building this stuff up, I ran into a handful of gotchas, like I was talking about before when I added the reset at the beginning. It's because when it went to write one of the configurations, it actually read the configuration first, and it had an old leftover data from the last test or something. And for whatever reason, they diverged, and they caused the test to fail, because one of them would read something and get a value, and the CircuitPython one would read something and get a different value. It didn't actually matter because they were about to change the value anyway, but it caused the test to fail. So like, that's when I added this, and this skill file documents like why that was added, and also a couple of other, maybe 2 or 3 other issues that I ran into while writing these initial tests. So this should make it so that our friendly LLM agent friends can create this style of test for us and even iteratively run the actual PyTest script and go back and examine the output and be like, you know, maybe this is the reason why. Possibly I could fix it by adding a sleep here, or, you know, we need to make sure to do the reset at the beginning if we forgot, that sort of stuff. So this, I think, is going to be super helpful moving forward for whenever there's new breakouts coming out. We're sort of porting the driver to CircuitPython. So like, for anyone who doesn't know kind of the way it works, when a new breakout comes out, Lady Ada will make the Arduino driver typically, sometimes with help from some of the Arduino devs like Tyeth, and there's a couple other folks, Brent, if it's an IO thing or a network thing. So there's a couple of folks who work on the Arduino side of things. So that Arduino driver gets written first, and then either Liz or I, currently one of us, will take the Arduino driver, re-implement it in CircuitPython, and then also do the Learn Guide, which has pages for both Arduino and CircuitPython, as well as pinouts and downloads and stuff. So the whole goal here is to get a suite of tools built up to make that conversion process very easier to do, and also easier to validate automatically. Be able to put an agent to the task of like, make sure these two drivers are A, behaving as expected, and B, behaving identically, because realistically for most time, you know, most cases, the CircuitPython driver and the Arduino driver are intended to do the exact same things. They're just two different implementations doing the exact same thing. So this goes through in a cold calculated, you know, iterative way to be able to say, like, through the entire driver, through every single setting, on every single configuration, are they behaving the exact same when you set those values? I think another test, which I haven't done yet, but I think another one that I will add to this eventually, is a data test. Right now, this is all set around testing the configuration, really. It's like the range and the data rate and the performance mode. These are all configuration settings. But I think a data test would be good as well. So like the LIS3MDL, that's a magnetometer. It gets an XYZ magnetic reading as its like data output. We should have one test where this would rely on, in this case, the sensors being in the same orientation. So like, you'd either need to hold them down like this, or you would need to, like, ideally I would build a rig or something that could hold these, right? So they would be held in the exact same way, and you would run a test and it would get a data reading from it, and it would make sure that the data reading is within, you know, 5% or whatever of each other. Like, it could have a little bit of variance because they are still you know, separate sensors. Like maybe one is tilted ever so slightly differently because the thing's not perfect, but generally they should be really close if you take a reading from two of them in the exact same sort of place, right? You know, a light sensor would be the same thing. You have two of them in the same room, the same lighting, right next to each other. You get a data reading from it, and that data reading should be, you know, within 5 or 10%, you know, if not tighter, between the two different devices. So that's one that I think we'll still add at some point, but it's not there yet. But this is what I have been working on. I did want to show it off. And then I think next I'm just going to go back to what I did last week, which was this light sensor knob NeoPixel thing. Try to hope that this cat eventually finds something else to do. He's overwhelmed with how nice and sunny it is. Doesn't know what to do with himself. This thing's kind of far over here. And I've got the next couple of breakouts coming this week, so they are ordered and on the way. So I'll be able to put this to test with an actual new driver this week. The VCNL 4030 is the next one that I'm working on. But for now, we're just going to go back to the AS7343. Yeah. Need the Arduino anymore. Not need the Fruit Jam anymore. And instead we have no Neo. Well, we have a NeoPixel strip. Pixel strip right here. Feather TFT. And then a rotary encoder QT. Knob there for the rotary encoder. And then there is the AS7343 multispectral light sensor there. The idea is you kind of point the NeoPixels at the light sensor, and with a bit of shoving the right things on your desk in the right spot, you kind of point them at each other. And then from there, you can turn the knob. Sand is actually the one that's in the way, isn't it? Should have probably done 2 longs. As I turn the knob, the NeoPixels change to different colors of lights. And because the NeoPixels are shining on the light sensor, the different channels of lights change as we do that. Probably at a... Yeah, none of these... One second, I'm going to grab just a little tissue to put over the top, which kind of diffuses the room light because it's nice and bright in here from the windows and everything, and helps get the readings to be actually just from the NeoPixels. Mangled. This kind of diffuses the room light so that we're getting essentially just the sensor pointing directly at the NeoPixels. And there you can really see the colors now are matching the wavelengths of light that it's emitting. And it doesn't come through super great. This is kind of like a torture test for the camera to be having NeoPixels running and this tiny little TFT display But these bars are actually colored as well. It kind of like this whole section here sort of looks like white on the camera, but there's actually greens and yellows. These are actually sort of a rainbow of colors of bars here. This example, I'm just not set up to like capture it super well with a real camera. But what I would like to work on specifically is refactoring it to use uplot. Shout out to some nice from last week who pointed me to this. Device workspace, others. Okay, yes. Cat distractor. Ouch. That interested. Okay, so this thing can do bar charts with a bunch of different colors. But there was around a different. Crazy, like an oscilloscope there. The palette. Yeah. This is what I was. Okay, so the way this API works, you import plot and color, and you import bar, and you create a plot, which it looks like gets a size, background color, a padding, and a box color. Then you have data in a list, and you have labels, I presume, or something. Sure what these would be from the example. They don't show anything. Guessing it's optional whether or not they show or something, but I assume those are labels. There's 5, 6 of those, and there's 6 of these. So next we create a bar. Bar takes the plot, which we created here, takes the labels or whatever these are. It takes the data. It takes a color of some sort. This is like reddish. Oh, and it takes a color palette. You know what this probably is? You probably could pass it a single color and it would make all the bars the same color. Or you could, well, and or slash, you need to do both technically because this is a required argument, doesn't have a name. Maybe if it has a default, I don't know. Anyway, it looks like it's required to me. So you give it one and then they would all be the same. If you want different, you also give it a list of colors like. Gloves off so I can pet the cat and not get him all hairy, and then he just walks away. Put my gloves back on because my hands are cold. It would be interesting to see the predicted color levels on the graph too, the levels expected based on the RGB value. That would be kind of cool. I don't know how that would be calculated. I don't know how to get those expected values. I do find it interesting. I've noticed like you can very clearly see the fact that it is RGB based, right? Like a NeoPixel has three LEDs inside of it, right? It's got the red, the green, the blue. And one thing I have noticed is like we're kind of peaking in towards blue now, and we're going to transition towards red next. And you can kind of see like the blue gets maxed out, the other things go away, and the blue stays maxed out, and then you can kind of see the reds start rising over there, and the blues stay maxing out. And with each chunk, the reds sort of go up a little bit, and the blues stay the same, and then eventually you hit the midway point there, and you can actually see finally when the blue starts turning off a little bit. And you can kind of do the same with the green there. So like the green is turning on and it's making the yellow and the green bars rise. And you can really pinpoint that midway point where you change over from just one rising to one falling and the other one rising, which is kind of interesting. Lost interest again for a minute, and my hands are in fact still cold, so gloves back on and hope for the best. All right, so we've given it the color palette, and then beyond that, display show. So we use root group now, but it looks like it's a group, so we should be able to set it or put it in the main group or whatever we want to do. So that looks all good. The next one here is updating values, which we're definitely going to want to do, so we should check this one as well. So everything up to here looks like the same to me. Well, in this case, actually, they've done it in a slightly different order. So here they show it on the display, which is like setting the root group. They do that after they create the bar. Here they do it the other way around, actually. So they show it, set it to the root group before they create the bar. So here's creating at least the first bar. I don't know if you have to recreate it or what, but this is creating the first bar. Give it the plot, the labels, the values, color. I don't know what the Boolean would be. There's the color palette with all the rest of the colors. This one's also setting a max value, which I don't think this one did. Yeah, this one had, oops, wrong one, right here actually, but it still had no max value, so that's a new thing. Then it is Ryan range 20, values changed. Update values, values changed. Then it's add +1, add -1. Not sure. I don't quite understand this add number. Okay, so it starts on 1. It's going through all these numbers and it's adding add to them. So it starts on these, this is on 1, and it adds 1 to all of these to change the values, and then this goes to 2. So the next time around it's going to add 2 to all of those, and then 3 to all of those, and all the way up to 20 basically, because this is adding 1 every time. And then here it's doing the same thing. It's adding add to all of those, but it's counting down. So it's going to go 20, 19, 18. I think, at least. It's going to get over 100, I would think, though. So I'm not sure if that just clips or what. But in any case, it looks like the way we change data is just by saying update values, and we pass the new data set, which is super easy for us because we already just have a list of data. We can pass it right into that. Okay, so let's try to get this set up. I'm actually going to make a copy of this as well. This is the bitmap tools chart. And we're going to end up with this one, which is the uplot chart, microplot chart. Human perception is nonlinear, whereas I expect the color spectrum sensor is non-weighted. Another enhancement would be to weigh what the sensor detects. I think we'll probably weight what the sensor detects to match the intensity that I would see. Might open the door to mathematically filtering it for dog vision and stuff. Oh, that would be interesting. I thought about using it as a lighting, almost like a lighting configurator. So my wife is wanting to take some pictures of prints that she's been making. She had it hanging on a door. We were talking about the way it made a shadow. And I was thinking about this thing and wondering if it could, and the light that was causing the shadow is like partially from a window. I was wondering if I could use this thing to like measure the light from the window and then use NeoPixels or some other, like I have the Wiz Smart Light as well, use some other artificial light source to like match the existing light source but pointed from the other direction so that we could get a second light that's the same brightness and the same color as the existing light and bring it in from the other angle to like counteract slash offset slash make it so there's not shadows. I don't know if that's actually going to work how I imagine, but something I was thinking about using this sensor for, which sounds similar in some ways to that. Not about human eye perception as much as it was the camera in this case, but I was like, I wonder if that, being able to measure that and then have another light and like tune it to be the same measurement, I wondered if that would work. Okay. So we need import these things. And we will need to install this, which I believe this is in the community bundle. So I think we can circup. I'll grab the Python one. I kind of like the Python. I don't actually know if there's a space there or not. This is inconveniently wrapped. There's no space there. I don't like installing the Python ones because then I can go look at the code. A light meter with a mathematical color filter setting. Cool idea. Yeah, thank you. All right, so yeah, this happens sometimes. I've noticed this using Circup from the Raspberry Pi. So like I have this whole Raspberry Pi. I'm remoted into it. It's all set up with the agent and different stuff running inside of it. I've noticed that Circup does this. Sometimes you run Circup install and it fails with this permission denied thing. Effectively, or at least that's what it's been in the past. It doesn't. Actually say permission. Oh, it does. Okay, yeah. I mean, not exact, but not permitted. Permission denied, basically, right? But I run it again, and it's like it's already installed. So like it did succeed. It just also printed all this stuff about failing. I don't know what's going on with that. At some point, I will look into that a little closer. But in this case, since it like actually works and just prints that it doesn't work, I'm not super worried about it. Okay. One issue I think we're gonna have is I think we need to get back to 24-bit colors. Yeah, I'm pretty sure we're going to need to get back to 24-bit colors. We should be able to fix the colors at the end, though, honestly. I think we could do most of this and not worry about it. They'll look weird, but then we'll know that we need to change them. And there's some chance that I'm wrong and that it still just works, but I don't think so. Not sure. So sometime after we have the display, we can create the plot. We didn't get to for a minute here. There we go. So background black, box color black, adding 10, that's fine. Actually, we maybe want to go with a little less than 10. I don't know, we'll see what it looks like. We don't need dummy data because we have sensor data. We do need to get the readings we care about from the sensor data though, because okay. Yeah, the thing is the sensor itself outputs more data than our chart has. Our chart has 12 bars, but the sensor itself actually outputs more. There's a couple other things it outputs, basically. And this, by looping over only the values in, well, looping over the range of num bars and then accessing the things from bar channels, it is making sure to only use the ones we care about. So currently we do not actually have our data in a list. We do need to do that. I mean, it's in a list, but it contains more than we want. We need to get it down to a list that only contains these. And I almost think we want to probably have like a what is this? This is like trim, kind of trim data for plot. So this takes the raw plot plata. What's going on with the plata there? Trim data for plot. So this kind of will take the raw data, which contains extra values that we don't need, and trim it down to just the values that we want. We get a list, we loop over the range of the num bars, and we can just grab each one. Actually, why don't we call this get plot data? And it will just take it, it will take a reading. So we just call this, we don't have to pass data in. It'll do the reading in here. Access this, and then we'll append it to this. We build up a list of the ones we care about. And then when we're done, we just return that. So now we have a nice function that will get us the data ready to go in a list for our chart. Move it up there so it's kind of out of the way a little bit though. All right, so now we don't really need to create this labels. We'll just use this. I assume this is labels. It's always just calls it A. We'd have to look at the code or the docs to find out for sure, but I'm assuming that must be labels. I think I skipped a comment $sign there. Yeah, okay. So we create a bar, we give it the plot, we give it the labels, we give it the data, which is going to be get plot data. We give it, I'll just give it the first color, the bar color 0. And then here we'll give it all of bar colors. And again, I think this is not going to look right because I do think we have 565 colors here. I think we actually need 888 colors. Are then going to get converted to 565 internally, but I think that's kind of how it is. I don't think we want a max value. I think we want to just let that go to whatever. Yeah. Or instead of max 100, maybe what we could do is max, like maybe we could get the max of the data from the list. This might give it the same behavior as the bitmap tools implementation, which the bitmap tools implementation, it's like scaling to where whichever light channel has the highest reading will get a full bar, no matter what the reading is. The reading could be 1,000, it could be 10,000, it could be 7. Like, whichever one has the highest reading will get a full bar. And I suspect this max value might do a similar kind of scaling situation. I'm not positive, but that's kind of what I'm thinking. Okay, so this would set the initial data, all good, and then when we want to change it, all we do is my bar, we call update values. I'm actually going to change this to bar chart. We could then call update values and just give it a new one of these. Oh, maybe we need to change max value too. Let's take this back out for now, because we might need to change max value since the data would change as well. So let's get rid of these. It looked like plot is what got passed to display.show, which means it should be like a group or something that we can append to another group. We can set that to the root group there. This was testing because the display was not working at first, I think, if I recall correctly. This is refresh interval last time position. Okay, yeah. So do the NeoPixel encoder stuff. And then here's where it's going to go and update the display. So it updates the display only refresh interval times, or every refresh interval amount of seconds, I guess. We no longer need to really take readings like this because we're just going to get the readings from that function we created earlier, which does this for us. And in fact, I think we really don't need like most of this. If I had put this into a list before, we could have made this whole thing here just use the max function. This is basically just using the max function. It's kind of interesting. Or just implementing the max function, I should say. Yeah, I think we don't need any of this. And in fact, now it's just bar chart. Was it update values or update data? So update values. We give it the new ones, which we can just call that again. Nice. Yeah. Make sure I saved the right file. No, I totally did not save the right file. Here's how we're going to do this little swap-de-doodle here. We're going to paste CodePy into here. I'm going to take this. Order I let go matters. Okay, that's a little what I expected, honestly, was that it would crash the first time. No module display text. Touché. It's interesting that it didn't install automatically. Must not be a requirements or something. Usually it will. Usually Circup will chain, right? Usually it will get you all the things that that one requires. But in any case, we can just want to be able to not have to go out and into this every time. So let's go get a new one of these. Circup is a Python installed thing, so you gotta be in the virtual environment. Yeah, so like sometimes you get, especially on ones where there's multiple like this, like it was failing with that operation not permitted thing or whatever. And it did it, like the first one did it, but it succeeded, and then I ran it again, and then the second one did it, but it succeeded, and then I ran it again, and then the third one, for whatever reason, just succeeded the first time, but like had to rerun it a few times. So yeah, I need to look into that. I don't know what's going on with that. I think that that's just something to do with the way the Pi is interacting with Circup. So hopefully I'll be able to image a Pi with a plain Raspbian image and replicate that and then diagnose it from there. If it is actually something in my stack with the agent, or the way I've done my permissions, or the way I've linked the USB storage, it's like kind of have a couple of different weird things set up in my situation, in which case it's on me. Maybe I'll fix it. Maybe I deal with it. But if it's actually broken for all Raspberry Pis, then we definitely do want to fix it. In that case, I would definitely like to get fixed. Now it should be able to run. At least try it for the next thing. Nice. Okay. Yeah, that worked. Okay, so there's like a padding. I don't know if that was padding between bars or not, but there's actually kind of a lot of space between bars. And then the colors are totally messed up, right? The colors of the bars are like all blue and teal and wrong. So that is the 565 problem. One thing I don't remember, so I converted those. Did I convert those to 565? Did those start as 5? They started as 565s, but I converted them to. Did I convert them? We did. We had a converting thing, I thought, at some point. I think I went down the road of. Oh, they're right here. Yeah, yeah. Okay. I converted them to 888, and it turned out we didn't actually want them that way. Turned out we ended up needing them as 565 for the way we did it with bitmap tools. With this one, I think we actually do need them 888, and again, like internally, they get changed anyway. There we go. Okay. Now I think they're the right colors, but now our problem is the amount of space between them is a bit too much. I don't know. So when I saw padding, I assumed that meant padding around the outside of the whole chart. I mean, that must be what it is, right? Because this does not have. Really, padding would be on bar if it was. Probably don't want that on the side. Okay. That must be around the outside of the whole plot. Which means we need a way to get those bars for the bar chart to move in some. Because I think we had very little. We had very little space in between. Maybe like 1 pixel only might be the space in between, 1 or 2. I wonder why this is printing. Is that in my driver? Hopefully that's not in the public driver. Oh, it's right here. Okay. Probably just came from the example of the QT spinner, QT rotary encoder thing. All right, let's look at bar. See if we can coax it to be why didn't that work? Huh. Actually, if you do that, they'll both change. This one doesn't let you change from the side, that's why. Well, only when it's in that mode. Weird. Oh. Bar space. Sounds promising. Space in pixels between bars. Beautiful. That's exactly what we want. Report goes out to Zé David Posada. This one, bar space, is an integer. Will need to be after these. Need to spell it correctly as well. Remember if it was one. I guess we could see from here, but what? Oh, right. Okay, so yeah. This is not bitmap tools. This is what we copied. Eat this. Up here is bitmap. We have our gap 3 pixels actually. Okay. There we go. Okay. So now the thing that is awkward is it's not doing that scaling anymore. A bunch of the bars are just fully maxed off the top of the screen. So we really do need that scaling. So max value for filled unprojected bars. We'll set up the maximum value for the bars. This allows the user to update the bars in real time. I don't really know what that means. Let's turn it, well, let's set it to the initial one, but it's not going to work very well because the neopixels will be off the first time. We need to change it every time, I'm pretty sure. Does it go to a public thing? Let's change it after the fact. IMAX. Looks like it's in pixels, actually. Oh, why? Plot scale. Projection. I think that's 3D. I don't think we want that. Call it max value. What is, oh, plot.scale. Plot.scale do? Well, so it's a group, so that's just display IO scale. For I and Y. List of Ys, the Y data. What? Oh. Okay, this is not labels and data. This is X data and Y data. And in the case of a bar chart, there's not really any such thing as X data. Well, I mean, you could have a bar chart that's 90 degrees the other way, and then you could have X's and no Y's, but typically you would not have both, right? If it's a line chart, then you could kind of like have both X data and Y data. But in our case, we don't really have that. We pretty much only have one axis of data. We have multiple readings, like different light channels are what they are in our case, but all on one axis. So we're not passing labels. We're actually just passing dummies. I don't think it probably does not even matter what we pass. Maybe it needs to be the same length of plot data. That might not even be the case. Honestly, I don't know. The maximum value for the bars. Okay, yeah. It is, well, so if it's none, it gets set automatically to the highest value when it started, when a init was called, right? This is inside of a init. This is going to set Y max to that. There's new Y max and new Y min, which is odd. Okay. Update values. It's a list of values. Loops over I, an element in enumerate bars. Bars is what now? Bars is a list of rectangles. Kind of rectangles. Vector IO rectangles. Okay. So then when you update data, it's looping over those vector IOs. It is calculating the height, and it's changing the height of the vector IO rectangle, which will update how big it is on the screen. And then it has to change the Y as well because they're actually top left anchored. So we need the Y to go up in order to push the smaller bar down the screen. Yeah. Okay. So, So unfortunately, the public API, it looks like, is just add values, and then here it is working off of that's Y min. We want Y max? I mean, this isn't considering the max at all. Or is it by way of doing the min? The min is derived from the max? So it gets a little weird here because we have self.newMin, which is on the bar instance. But it looks like we also are having a plot.newMin, new ymin, and presumably there's an X one as well, but we're not using it. But it's private. Boy, I gotta be honest, I do not really follow what this max value does. But in any case, if you don't set it, it gets set to the largest of your input data. So that's what would be happening for us. So it is not in pixels, it's in data units. And if you pass it, it would be in whatever units you pass it in. And then it gets used, it gets set into this variable, and then it gets used in the calculation here for self.newmin and self.newmax. But those don't get used. This got set right here, and then nothing ever did anything with it. I don't think this would be doing anything. New ymin, new ymax. See, in the weird, so new ymin and new, these look like pixels, right? This is width and height in pixels and padding in pixels. Which makes sense, I guess, because this is calculating a y coordinate in pixels, it looks like. But why do these exist? I wonder if these never got implemented. Okay, create bars. If fill, I think fill. Well, it's the false, actually. What? The false. Boxes are filled. Okay, we passed true, though, right here. That's what this is. Okay, okay, okay. Okay. So fill is true. We do this. We call create bars. We're not doing projection, so we don't do that. We don't have any text, so we're not messing with that. Color index is getting updated, one for each bar, it looks like, so that it can go through the list of colors. Okay, so create bars. Was this mad about? Unexpected arguments, possible callees? I don't know. Not sure what it's trying to say. I think the arguments are slightly different. Max setting looks like an auto ranging option when equal to none. Yeah, but I mean, that's what the name of the variables sound like to me, but I don't think the functionality doesn't look like it's there to me, because max value comes in here. Either it's none, which in our case it is none because we haven't passed it, so it uses the largest one of the data. That gets set into this. Well, actually, okay, it gets considered here as well, though. Okay. I was going to say the only place where that's considered is these, and these don't seem to be doing anything. That's not actually true, because Ymax is here as well. But I'm not convinced this is... This would be correct. Because these we saw, these are pixel values. We're dividing by data units value. Randomly adding 2. All right, let's set it to something and see what happens, I guess. That's one way to find out if it does anything. The weird thing, like the hard part is what do I set it to? So I was going to set it to just the max one of the data, but it's already doing that automatically, honestly. So I don't think that's going to cause any change in behavior. $10,000 and see if the bars get smaller. Okay, the bars are way smaller. So weird. I do not understand how it's working. Okay, so the gist of it is, though, we need to get those, well, we need to get it updated, but the way it works is so, because I don't understand it, I don't know how to update it. We need to... I don't know how to apply it. We're just update values. Okay. So I mean, if we work backwards from here, update values is where we're giving in new data. This is referencing graph Y, which took into account that maximum. And it's also referencing plot object new Y min, but this did not take into account that max value. This is the plot one, which is the pixels ones, which are set here. These are set just by width height padding on the plot. So graph Y, we need to recalculate graph Y, which effectively I equals the seal of graph Y times the current value. Graph Y times the current value? I don't know what that is really. Graph, but if we just recalculate it the same way, I think it should work. So this calculates graph Y like this. We have update values. I want to make a def update max value. Eventually, it'd be nice if there was a Boolean. You could just set it to true and it would do this automatically. But for now, I'll do it this way. So update max value, new max value, int. You have to pass it, no default. Don't have, that's on self.plot object. Then ymax is the literal value because ymax was the, if you passed max value, it was the literal value. If you didn't, then it was the largest one. So in our case, we're not messing with largest ones. We're explicitly saying this is the new value. Yeah, I think I like, because we're also not saving the data values here, right? We get a new set of values. those immediately get translated into pixels and put to the height of these rectangles so that we can see them visually, but we aren't storing them either. So we can't like reference them from here to like update the max to the current max, right? Over on Twitch, Jamie P205 says, what are you currently up to? I'm working on a color sensor TFT demo. If we find wherever I set that huge number here and undo it. So inside of here, I have a color. This is a light sensor, color sensor, basically. Different spectrums of light this thing can sense. I have a strip of neopixels, which are just RGB lights. And I have a rotary encoder knob, which is controlling the neopixels. So as I turn the knob, the neopixels change color. And then there's the color bar chart on the screen. So as I turn the knob, the sensor senses different colors. The bar chart updates to show which colors are being sensed. It does work best when it's covered up, though, because it's getting a lot of ambient light from the environment right now. I had this little tissue here. So that kind of blocks it down to really only sensing the neopixel. And then more specifically, I am trying to fix it so that these bar charts don't run off the top of the display. Like a bunch of them are just maxed out, and we're trying to play with this max value range scaling API to make it scale these so that they're not off the top. I'm in uni learning all about this and Python, so hopefully I can learn something from this. Yeah, that'd be cool. Hope you do. I would encourage you to join the Discord maybe as well, especially if you're interested in microcontrollers and stuff. Datafruit Discord that's linked, or that's shown below me here in the chat. There's lots of folks around there always working on cool, inspiring stuff. So if you're looking for ideas, or even if you need help with Python, you get help with stuff there as well. So, all right. So this would update graph Y, and then this is using graph Y inside of here. So as long as we call update max value before we call update values, it should work now, I think, maybe. You can tell how sure I am about that, but. All right, so update. So we do need to get cur data, get plot data, data, bar chart, update max value, max cur data. There we go. That's what we're after right there. Okay. Yeah. Yeah, now we're back to this world where whichever bar is the highest, that one is maxed out, and the rest are sort of, graded on a curve, right? They're scaled to that max one so that we have one that's all the way up, and we have the rest that are sort of like relative to that one max one. And now we're totally back to being able to see that exact teeter-totter point right there where it goes from, blue being raised to finally blue being lowered. Or rather, it's really going from red being raised to blue being lowered. Because we have, like, blue is on here. I go one chunk and red went up some. Red went up some again, red went up some again, and then finally right there, both red went up some more, and finally blue went down some. or maybe just red exceeded blue. That could be the case as well. Not sure. We'd have to look in the. We'd have to print out the NeoPixel colors to be certain. Are the bars really off the chart, or is it? Yeah. They were. Well, I mean, they can't draw above, but they were not bounded by the display size, basically. Oh, stretch it out. Okay, but don't like pull your diaphragm muscle or something. Ah, okay. Whew. Okay. So we basically are there. We basically now have the chart version of the same functionality that we had with bitmap tools. And it's way nice because now our code is like more Pythonic, I would say, in a way. Like we have functions and stuff that say exactly what they're doing, right? We're getting the plot data, we're updating the values on the chart. In our case, we're split, so we're updating the max value and then updating the data values, rather than our code having all of this sort of gnarly pixel math inside of it, all of this kind of stuff. And then fill region, it's not that much math, right? It's just figuring out the four corners of a rectangle, so it's not like, trig or anything super crazy, but whereas here, now with the chart, we're a lot more like higher level. We're just like, make a bar chart and set the data to this. We don't care as much about the pixel calculations. Especially now that we figured out how to make the max value thing work. Like, it just does all the math for us to figure out where the bars should be and how tall they should be. Now our code.py doesn't care about any of that stuff. Just like, make a chart, put this data into it. Just super nice. All right. What do we want to get up to next? I think that yeah, I will eventually PR this. Need to clean it up a bit and change, like, I think I just copied this from Rotary Encoder Simple Test, so we'll need to update the copyright and fix a couple of things. Some comments that could be cleaned up as well, it looks like. But I think I will eventually submit this to the AS7343 library as an example. So it's kind of like involved for examples as far as we usually do them, because it requires the NeoPixel strip and the rotary encoder, which are like totally separate products, not really related to the AS7343 other than the fact that I decided to put them all together here. So like our examples are usually more tuned for one piece of hardware. So the AS7343 would be an example that shows you how to use that breakout without anything else. But I do kind of really like this all-in-one visual example. Even if you were trying to explain to someone the different channels of light, just generally speaking, I think this could be a really nice visual demonstration of that, right? Being able to just literally watch this bar chart change as you turn this knob and see the colors of the LEDs changing as well. Like, I don't know. I don't know if that would be physics class or what, but in any case, I find it like it unravels the mystery of how light works a lot better for me, being able to see this. So even if you're not really trying to teach someone about microcontrollers, this could be a helpful just visual demonstration of the channels of light, I think. So I want to get it pushed into an example. We'll get that PR'd into the repo. But I think I will clean it up a bit later on. It's a great example of dates and graphing closer to the sensor's intended use. Nice. Dates plus graphing. Closer to, yeah. I'm curious also to stick it with a plant. I need to plant, I got some catnip. Try and grow cross, knock on wood. Hopefully the the actual live cats are not going to find it until I'm ready to harvest it and give it to them. And grow it in a spot where they don't tend to go looking around too much. So we'll see if that ends up working or not. It might attract them. I don't know if it's actually, like, I don't know if they can smell it while it's growing or not, but I'm gonna try to grow some catnip, and I had this idea of hooking up like sensors and stuff to it so that we can plot over time, like Adafruit.io or something, take some readings of light and also soil dampness, temperature, humidity, kind of plot all this data, and maybe have a camera as well, and then eventually put together a time lapse of photos from the camera, and then all this data can come together as well. Future, long term, maybe start trying to see, like, create a system that can get feedback from all these sensors and then sort of care for the plant by itself. So like if you have the humidity sensor and the soil dampness sensor and the temperature sensor, maybe with those three things combined, if you also had access to a pump that would turn on the water flow, maybe you could have a Raspberry Pi or something in the loop that decides when to water the plant based on the sensor readings, the light levels, and all that kind of stuff. Oh, look at the light reflected off the leaves. That'd be interesting as well. Yeah, see the light coming, bouncing off of the things too, which this sensor is good for as well. This AS7343, it does have a white LED there on the top, so you can shine a nice bright white light onto whatever you want and then measure the reflection back as well. Cool. Or through a leaf would also be pretty cool as well. Yeah. But yeah, I think that kind of stuff. That's one of the things I'm looking to get into this sort of growing season. I need to get on it because I think definitely heating up here. But I don't know if we're gonna have any more frost or not. But we'll see. That's one of the things that's on my mind though now is like getting a couple of sensors and a couple of like maybe lights and a pump so that the microcontroller or Raspberry Pi, whatever it is, can kind of like read the data from the sensors and then decide when to act to help the plant out, give it more water or turn on the artificial lights, or if I wanted to take this super far, maybe get blinds with a motor and give the Raspberry Pi the ability to open and close the blinds to like give it more sunlight or not. I don't know if it'll ever need to give it less sunlight, but you know, interesting ideas floating around in my head. But I think I'm going to wrap it up there for now. We got, technically I could go like 20 minutes. I usually go 2 hours or less. We're about 20 minutes shy of that right now, but if I'm honest, these were the main two things I wanted to do, is run through the I2C validator, show what I've done there, and then work on this and refactor it over to using the microplot library, and we finished that up. So I don't have an idea for anything else to start, especially not anything that I can actually make good progress on in 20 minutes. I think I'll wrap it up early. Oh, nice. To measure the light through would give you a chlorophyll reading. Actually, I had not considered that. You could, yeah, that's another data point where it could be like monitoring that from the plant. That's an interesting idea. Housekeeping notes, I will say, so Tuesday streams, started up the Tuesday stream. We've done 2 of them so far. I'll be back this Tuesday over on the Adafruit channel. So that is the 24th. I'll be there 10 a.m. Central Time, 11 a.m. Eastern Time, 8 a.m. Pacific Time over on Adafruit channel. I will be filling in on Friday for the deep dive for Scott. Scott's out half of this upcoming week, so he's not around on Friday. I will do deep dive on Friday, and then I will be gone on next Saturday. So I usually stream here on my channel on Saturdays. And I think the way I'm going to do this kind of moving forward is anytime if I fill in on deep dive, I'll probably skip the Saturday after. So this Friday I'll be on deep dive, and then I'll skip Saturday. So I won't be back next week, the 28th. I won't be here on Saturday, but I'll do deep dive on Friday. I'll do my stream. Also deep dive with Tim, basically we're calling it for now until we have a better name, on Tuesday. And then anytime when Scott is around and he does deep dive on Friday, then I'll be here on Saturday 10 a.m. Central Time in this time slot. So that's the plan moving forward. Is I'll always be doing the Tuesday streams as long as I'm around and not sick or anything. I'll do deep dives on Friday whenever Scott is not around, and then if I fill in on deep dive, I will skip the Saturday afterwards. But otherwise, I'll do this stream here on Saturdays as well. And I think that is it for the housekeeping update. Yeah, so Tuesday is the next time I'll be back. Until then, I will say so long. Thanks for watching. Bid you farewell. Thanks for the folks in the chat. We had some good discussion around some of the stuff this week, so appreciate all of you in the Discord and on Twitch. And that's it. So long, farewell. I will see you next time.